So the objectives are the same objectives as last time because it's still all about linear equations, which is mostly a review of Algebra 1 and geometry and pre-algebra and all the stuff. Okay, ready? So last time I used the same slide, right? I said that there's three forms of the equation of a straight line, and the first one was slope-intercept. That's what the last lesson was about. This lesson is about the last two, point slope and standard form. We're good? We good? Jaden? Good? Okay. So the first one is point slope, right? And point slope form is called point slope form because what do you need to use point slope form? You need a point and you need a slope, right? It's in the name, point slope. Right? If you look at the equation for it, right? We're already familiar with like saying x1, y1, x2, y2. That's what you use for the slope. This one just got the x1, y1 because it's just one point that you need, right? That's what it is. It's a fixed point. Right? So we recognize the x1, y1 as being the point and the m as being the slope. Sometimes you're going to see that written like this. Y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. So, you know, they kind of fill in the formula for slope in place of the m, which is fine. Yeah. The x and the y here, those are variables. They're going to stay variables in the final equation. The x1, y1, those will be numbers that get filled in. But you will always have in the final thing, you're going to have an x and you're going to have a y. Right? Remember, the whole point of this is that we've got equations with x's and y's. So all we can really do is represent one variable in terms of the other, and there'll be infinitely many points that satisfy that equation. All we can really do is graph them. But we expect that we're going to have an x and a y in the equation. You'll see in the example, I think it'll be a little more clear. So what is an equation of the line through the point 7, -1, and with a slope of -3? So, you know, whenever ever, science class, math class, you know, anything technical like that, if you get asked to write an equation or to fill in a formula, I mean, pretty much you should write it down first. You know, write down the y minus y1 equals m times x minus x1, and then start to substitute. So in this case, the slope is pretty clear, right? The slope is 3. Where is that 3? -3, that's going to go right there. Right, the x1, y1 is the fixed point that we're supposed to substitute. So we'll put in the 7, it's going to go here, oops, and the -1 will go, oops, here. So just substitute in the place of those 3. Y minus -1 equals negative 3x minus 7. And let's see what they say. Yeah. Now, in the textbook right now, like the problems that you do in the homework, they would simplify the minus and negative, right? Definitely, they're going to say y minus negative 1 means y plus 1, and you should too, right? But other than that, they left it in the point slope form. Just leave it like that. And again, it has the x and the y now are variables. They're going to stay in there. Now, what if I said to graph this equation, what would you have to do? Solve for y, right? So we could put it into point slope or slope intercept form by solving for y. But they left it right here, which, you know, the only place you'll see that done is in this first couple problems. They say leave it in point slope form. Most of the time you solve for y, like we did there. Okay, so definitely simplify the minus and negative. I do see, especially in like this level of class, that you don't, and then when you're asked to simplify, you're trying to like somehow cancel the minus and negative on this side. It almost always leads to a mistake. I think you don't make the mistake if you see y plus 1, you're pretty clear that I'm going to subtract 1 from both sides. But you definitely simplify that. Don't try to do math on both sides when you got a minus and negative in there. Okay. So that's pretty basic, right? Given the point and a slope, you use point slope form because that's why it's got its name. So try to do the same thing with that. Write the point slope form if you have the point of negative 5, 2, and the slope of 3/5. It's minus and negative, which makes it a plus. Good job. So how are you going to simplify that? X minus negative 5. Right. Right. Check a couple more. Y minus 2. 3/5 x plus 5. Okay. So, I mean, what should it be? I'll show more detail than it otherwise would, but y minus y1 equals mx minus x1. We're going to put that goes here, that goes here, and that goes here. Y minus 2 equals 3/5 x minus negative 5, which will be simplified. Y minus 2 equals 3/5 x plus 5. Right, that's point slope form. Now, it's not normal, honestly, that when you use the point slope form, that your entry point is that somebody has given you the point and the slope of a line. What's more common is you're given 2 points. That you've got 2 data points, and you want to turn that into the equation of a line. So this example says the line passes through these 2 points. What's the equation of the line in point slope form? Well, again, what 2 pieces of information do we need to use point slope form? Slope and a point. But we don't have that. We have 2 points. So what can we do as a first step so that we can use it? Yeah, calculate a slope first, right? If you got 2 points, then calculate a slope. and then use one of the points and the slope you just calculated in the point slope form. All right, so let's see. The slope, the m, right, would have been y2 minus y1 over x2 minus x1, 7 minus 0 over 0 minus negative 5, which is 7 over 5. Okay, now we've got y minus y1 equals m times x minus x1. Now, I'm pretty sure they say to put it in point slope form, okay? Now we got our slope, okay? Now we need a point. We've got 2 points. Which one do you have to use? Doesn't matter. You can pick either one. Just pick a point. Sometimes you're going to do the one that makes it easier. If you don't like doing those minus and negatives, then use the 0, positive 7. Then you won't have to worry about that. Let's say if I use the 0, 7, I'll do it over here, right? 0, 7. Then I get y minus 7 equals 7/5 x minus 0. And if I use the other point, negative 5, 0, then I got y minus 0 equals 7/5 x minus negative 5, which is x plus 5. So depending on the point you use, it's going to look different. Your answer would be different. And I don't think that they tell you in the problems which to use. But if you solve for y, put it in the slope-intercept form, it will do the same thing. Watch. So here's the y minus 7 equals 7/5 x. Y equals 7/5 x plus 7. Okay, this one, y equals 7/5 x plus, and then 7/5 times 5. The 5s cancel, plus 7. So they're the same line, even though they will look different depending on the point you plug in the point slope form. So given 2 points, calculate the slope, then use the slope and 1 point to calculate the line. So try this one. And just so that we all get the same answer, right? Once you've calculated the slope, use this point as your x1, y1, and then write the point slope form of a line. So what was the slope? The slope should be 3, right? Again, use this as your x1, y1. What do you get? Get it? Still working on it? Y minus 2, 3x minus what? You trying to get it? Yes. And correct. And do it? It's just a slope, right? You have to keep going. Oh, is it a, no, you didn't do the actual point slope form. Done. That's right, you're done. You wouldn't even simplify from there. So it should look like, if we all use the same point, y minus 2 equals 3x minus 3. Because it's more common if you ever were to use, and to have to make an equation of a line. You may think, well, I'll never have to do that for myself. But I'll tell you, there's a lot of times as a teacher that I've got to make scales that take me from one graded thing to another. And it actually comes in pretty useful. For example, let's see, on the AP stats test, right, there's two parts of the test. In the end, it's like 63%, I think, gets you a 5 on the test. So when we're doing practice things in class and we give like a mock AP test, I'm thinking to myself, well, if somebody could get a 5 on the AP stats, I should give them an A in the class. So that 63 ought to be like a 90 on our grading scale. So I come up with a scale that says something like 63 maps to 90. The input of 63 should give me an output of 90. And I still want 100 on the AP. If somebody got 100, that's still 100 for us too. So there's my 2 points. And I use point slope form and come up with a line, you know, solve it for y, so it's something I can stick in the calculator or put it in an Excel spreadsheet or something like that. All right. Any teacher might have to do that, not just a math teacher that has different scales of things that you're dealing with. So it can be useful. Okay. The standard form, that was everything you ever needed to know about the point slope form. This is the standard form. And the standard form is, and we use capital letters here, AX plus BY equals C, where A, B, and C are real numbers, according to this definition in this book. The main thing about standard form, both the X and the Y term are on the left. Usually you're going to write the X term plus the Y term equals a constant term. That's the standard form. And this book, in all of its editions, always says that these are real numbers. They both can't be 0, because if they were 0, then you wouldn't have an equation. It would be 0 equals a constant. You know, that's not going to give us a line. But 1 could be 0. Most of the time when I've dealt with this before, they always say they want to have integers, not any kind of real number. You don't want decimals or fractions or irrational numbers or anything like that. You usually want integers. And you usually want the first one to be a positive one. So you're leading off with a positive number, if you can. This book says any real number, so we just deal with their definition here. I've seen in some of their problems what they say is make sure that all the coefficients are integers at the end. But a lot of times that's kind of like wrapped up in the definition. Now, the reason standard form, the only real use for it, which doesn't really give us a lot of practical use in this class now, the way the curriculum is developed, is it makes it very easy to graph a line using the intercepts, the x-intercept and the y-intercept. Because, again, what did we say about these intercepts in the last lesson? The way you find an x-intercept, since the y-coordinate is 0, you substitute for y equals 0 and you solve for x. The way you find a y-intercept is you substitute x equals 0 and then you solve for y. Right? Those two pieces of information work no matter what kind of function. So it's one of those things that it's not like one disconnected thing that we're asking you to memorize. It's something that actually relates to everything else that we do from now on, right? When you say find an intercept, you should know, okay, plug in the other variable as 0 and solve. And you'll see why when we do the example, when a line is in standard form, it's very easy to do. Very, very, very easy. Okay. Janine? Keep going if you're writing. Like I said, I mean, I should like highlight that. Sophia, slow me down if I go too fast. Okay, so now, what are the intercepts of this line? 2x minus 4y equals 8. Graph the equation. Okay, let me write this here. 2x minus 4y equals 8. Right, again, how would I find the x-intercept? Substitute y equals 0, right? So 2x minus 4 times 0 equals 8. So 2x equals 8. So x equals 4, right? Now, think of it like this. Watch, see if I can pull this up. Let me get a circle. I think that'll work. The thing is, when you substitute the y as 0, you know that whole term is going to go away. Make it a little bigger. That whole term is going to go away. So you're really, at that point, if you just cover up the second term, then the equation that's left is 2x equals 8. So x equals 4, right? Same thing if I want to substitute x equals 0, just cover up the x term. If on your paper, just put your finger over the x term and solve what's left, right? What's the equation that's left when I cover up the 2x? Negative 4y equals 8, right? Negative 4y equals 8. Divide by negative 4, y equals negative 2. And so just one at a time with your hand, since, cover up the y term, solve for x. Cover up the x term, solve for y. There's your 2 points. So on the graph, if the x-intercept is 4, then you go here. The y-intercept is negative 2, then you go here. And then you just draw a line, because that's all you need is 2 points to draw a line, then connect those two with a line. Right, it just takes the 2 points to graph a line. So use the intercepts. If it's in standard form, that is like the one thing that makes standard form very useful. It's easy to graph using the intercepts. Just cover up one, cover up the other. Let's try this. Oops. Try to do it on that one, right? 3x plus 5y equals 15. Find the intercepts, plot them, and then connect them with a line. Where's transparency? I don't know. Okay. 5 and 3. Good job. Iteration. Okay. 5 and 3. Perfect. Five and 3. So now draw your graph. Right? That's the y-intercept. That's the x-intercept. Connect them with a line. Good job. Did you draw a line? Good job. doing it, Cody? That looks good. Good job. Which is yours? Yeah, a little bit wrong. So now make yourself a graph and plot on the y-axis at 3, and the x-axis 5. Connect them. Okay, so you, again, cover up. I mean, when I'm doing it, I just put, if I'm doing it on paper, I just put my finger over one, put my finger over the other, solve what's left. Right, this one, define the x-intercept, cover that up. 3x equals 15, so x equals 5. Cover up the other one. 5y equals 15, y equals 3. Right? Graph those two. 3 and 5. Draw a line. Done. You know, it's the one use of a standard form. We used to teach something. We used to teach a chapter which is called systems of equations, which is we have more than one equation to solve, which you supposedly already had in Algebra 1. When you have two equations and two variables, then the solution is where they intersect. And if you do remember any part of this, then you're supposed to have used either substitution or elimination were the methods we used to solve. And for that, it was useful also to have it in standard form. And then later in the chapter, there was a thing called linear programming where it was you had to graph these lines, and they were always given in standard form. And sometimes because it was real world kind of stuff, it could be kind of awkward numbers to deal with. Much easier to solve by just doing the cover one up, cover the other, make your intercepts, sketch a line kind of thing, than trying to solve for y and use what you know about slope-intercept form. So let's see. That is it. Right? Trying to think. Next class, we do absolute value equations, which are a form of linear equations. And they're used a lot. We do actually, the next one we do will be absolute value and what you call transformations. And that's something that's just, it's emphasized a lot. Not just in SOLs, but in the textbooks and everything, trying to understand things. Graphs as transformations of other functions. And it's best shown with an absolute value function. Homework is that.